Hi guys, welcome back to another video. So in this video we'll be solving this problem, number of islands. It's a medium level problem. So let's see the problem statement. Given a two-dimensional integer matrix of ones and zeros, return the number of islands in the matrix. Okay, a 1 represents land and 0 represents water. So an island is a group of ones that are neighboring whose parameter is surrounded by water. Note, neighbors can only be directly horizontal or vertical, not diagonal. Okay, so let's see the sample. This one and this one are all connected, this three ones. So there's only one island, so output is one. In this is the one island, this is a second island, this is the third island, and this is the fourth island. So output is 4. Okay, and this is the one island, this is the one, so output is 2. Okay, so let's see how we can find the number of islands. So we are given a matrix. Suppose this is a matrix where 1 represents an island and 0 represents the water, and we have to find the number of islands in this matrix. Okay, so to solve this, what we can do, we can use a DFS in this, which is def first search, to solve this. So what we'll do, we will traverse through the matrix. Suppose we are traversing through the matrix by applying two loops, and suppose our I is here in this cell. So if we encounter an island, the value of this of the land is 1. So if we encounter the 1, then what we'll do, we'll apply the DFS starting from here. Suppose its coordinates are x and y. Suppose this its coordinates are x and y. Then we will check at this will be y minus 1, this will be y plus 1, this will be x minus x plus 1 comma y, and this will be x minus 1 comma y. We will check at all the four directions if they are if in any of the direction there is one present or not. If there is one present, then at that point we will check all the four directions. So suppose first we check at this direction, and if we got the one, then we will check to all the four directions of this. And after before checking that, we will make this as 0. Suppose we got 1 here, so we will make this 0. We will make this 0 so as to we didn't repeat any island, because if we repeat that, then it will go into an infinite loop, because it will keep checking at the right, then at the left, right, left. So before checking, we will mark this at 0 as the 0, so that we don't get any repeated land. And we'll go here, check here. At here it will go out of the matrix, and also here it will go out of the matrix. So we have to put a condition, like if going at this direction, the coordinates doesn't go out of the matrix. So at the right there is 0, so a function will get terminate. At down there is 1, so we will make this as 0. So we will make this as 0, and we will check it's all the four directions. So we'll check here, so here it's 0, so it will get terminate. Here it's 1, at the down here it's 1, so we'll again make it 0. We'll make it 0, and we will check its all directions. So at here it will go out of the loop, out of the matrix. At down it will also go out of the matrix. At the right, here 1 present, so we'll make 0. We'll make 0, and we'll check its 4. So here at the right is 0, at above also 0, at down it goes out of the matrix, and at the left it's also 0. So the function will get terminate, and it will go back to the function from where it came. So it's all after checking the all four direction of this, we will also go back, and in this way we will make 0 to all the connected lands horizontally and vertically, and after making it, we will terminate the function, and we will just increment our answer from 0 to plus 1. We'll make answer, so our answer will now be 1. Answer will become 1 here. And and we got the 0. So let's erase this just to make it clean. So we got all these to 0, and then we will traverse the matrix. So I will now come here, so it's 0, so we don't have to check. Then I will come to here, and also it's 0, and then I will come to here. So after I comes here, what we'll do, we'll again run a DFS. After marking it 0, we'll check all its four direction. So at the right there is 1, so we'll make it 0, and then we'll check here, 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 and after checking all the connected lands will turn into 0, so we don't get the repeated land. And after this DFS function eliminates, we'll increment our answer, so answer will come to 2. And in this way we will check here, so it will come to 0, and then we'll check here, so these both will be 0. So finally our answer will be, there are 4 islands, so our answer will be 4. So this is the method. So in this way we can solve this. We just have to traverse through the lands, and if through the matrix, and if we encounter a land, we will check all its four direction, to all its four direction, whether there is land or not. And if there is land present, then we will check its the all the direction of this land. And in this way all the connected lands will turn into water, or will make it so that we don't get repeated land. So the time complexity of this is goes to O of n into m, where n are rows and m are columns. Okay, so this is the way we can check. So let's code this solution out. So first we will store the rows and columns of this matrix, and then we will traverse through the matrix. And we will take a answer variable, and if we put a condition if there is land or not, and if there is land, if this condition fulfills, then we will make then we will run a DFS here. So it will pass these parameters to a DFS, and we will increment. After the DFS function eliminates, we will increment our answer. So let's make a DFS function. So first of all we will make this to 0. We will convert this land to water, and we have to make a for the directions. So this is the way we can create an array for the directions. Okay, k plus plus. So we will now store new coordinates. K of 1 plus j. So these are the x and y are the new coordinates, or we can say new the index of the new cell. And if this is in, first we'll check if it's inside the matrix or not. So y is greater than equals to 0 and y is less than m. We check that these coordinates are inside the matrix or not by applying these condition, and after that we'll check if this is land or not. If this is land, then we will run DFS to the at this point. So I think that's enough. So okay, and we will, after that we will return answer. So let's run. Okay, we got accepted. Let's submit. And yeah, we got the success, and took only 8 milliseconds, which is faster than 96.09%. So that's good. So let's recap this code. So what we are doing, we are first storing the rows and columns, and n are rows and m are columns. And first you are initializing our answer to 0. Then we are traversing through these two loops to the matrix, and if we encounter an island in a cell, then we will run DFS at it. So this is our DFS calling function, and this is the main DFS. So what we are doing, first we are marking this land to water, and we are running a loop of to check to all those four directions. And for checking, we are creating a direction array, which is this direct which is giving the directions to the right, left, up and down. And we will first store these two coordinates, and we'll check if these two coordinates are inside a matrix, like the ith row and xth row and yth column. This is inside a matrix, and if it is inside a matrix, then we'll check if then we are checking by this if this is land or not. If this is land, then we will run DFS at this point. So we will pass new coordinates x and y to our DFS. So in this way, we will it will make all the connected lands to 0, and after doing it, we will just increment our answer to plus plus, and after that we return answer. So this is it. So thank you for watching, and I see you in the next video.